Well, hello, mathematicians, and welcome back. I got a couple of fun problems for you today, and we're going to take a close look at how to create a bar model that matches the problem. So, the first one up you see on the screen in front of you, Henry bakes 84 bread rolls and fruit muffins. After giving away 18 rolls, there are 5/6 as many rolls as muffins left. How many rolls did Henry bake? Well, the first thing you need to do when you are approaching a problem is to figure out the meaning of the problem, all right? So this one happens to be a little bit complicated. So what I want you to do is picture this man named Henry who's a baker, and he's got this, two huge trays, one containing rolls and one containing fruit muffins. And he had done all this baking, right? And he had like rolls that were maybe too many for the tray. And so he gave away 18 of them. And now there are still these two trays, one of muffins and one of rolls. And the muffins are noticeably larger than the rolls, right? So if the tray, what fits in the tray is 6/6 of a portion there. The roll tray only has 5/6 full. All right. So that's what 5/6 as many rolls as muffins means. All right. So let's underline those parts that we know. Well, we know that Henry bakes rolls and muffins. We know that he gave away 18 of them. And we know that there's a relationship between rolls and muffins, 5/6 as many rolls as muffins. And we also know that this is the question. How many rolls did Henry bake? That's what we're trying to find out. So let's go ahead and put some things on here. If I can, here are the rolls and here are the muffins. All right, and all together, we know that this is 84. 84 rolls and muffins, not 84 rolls and 84 muffins, but 84 rolls and muffins, all right? And so we know there's a relationship between the two of them, so we're going to start here, and we're going to say, all right, 1, 2, 3, 4, 5. This is our rolls. We're going to give them 5 squares. And here are our muffins. We're going to give those 6 squares because we knew that there were 5/6. 5/6 as many rolls as muffins. So the muffins have the full tray and the rolls just slightly left. But that's not all that we're going to put on the rolls. We're also going to put this dotted line. And we really don't know how far it extends. And it doesn't really matter. But that dotted line is going to actually be 18. Oops. This is 18. All right. And let's see. We also know one other thing, and that's that we are looking for this quantity right here. Okay. So, well, I think we can get to work now. We have drawn a picture that shows us exactly what happened, that he started with a certain quantity of rolls, gave away 18, and then now he's left with this relationship that is 5/6, right? The number of rolls as muffins. And so what might we do to get started? We have some numbers on the screen. How might we use them? Well, if you said that we can take the total that he started with of these rolls and muffins and subtract how many he gave away, that would be a good start. So let's do that. 84 minus 18 leaves us with 66. Okay, so there are 66 of these rolls and muffins left. Now, Is there a way we can find out how much 1 unit is? How many units do we have that we still have muffins and rolls for? Well, there are 5 units for rolls and 6 units for muffins, so 5 and 6 is 11. So if you take the 66 and divide it by 11 units, you are left with 6 units apiece. So each one of these squares is 6. It's worth 6 either muffins or rolls. Okay. And now, is it possible to find our question mark? Well, sure it is, because we have it all marked. We know that there are 5 units of 6 rolls plus 18. And using order of operations, we didn't have to put that in parentheses because multiplication and division comes first. So 5 times 6 is 30 plus 18. And that's going to give us 48. And that's the answer to the problem. How many rolls did Henry bake? 48. And we're done. Excellent. So let's go ahead on to the next problem. Jane's present age is 1/5 of her father's age. Her father will be 52 in 7 years. In how many years will Jane be 1/4 of her father's age? Okay, so what do we know? Well, we know she's 1/5 of her father's age. We know that in 7 years, her father will be 52. And we know the question that we're asking. In how many years will Jane be 1/4 of her father's age? So the relationship starts out like that. Here's Jane's age. And here's her father. She has 1 unit and he has 5 units. Okay, because she is 1/5 of his. All right. So can we figure out what his age is now? Is that possible? Well, sure. We know that he's going to be 52 in 7 years. So if we subtract 52 minus 7, we wind up with 45. And that is her father's age now. So this is 45. So 5 units is 45. So 1 unit is 9, okay? And that would be 45 divided by 5. Okay, so that means that now Jane's age is 9 years old. Okay, so let's see, is there any other piece of information we can glean from this model that we have shown? I think we could ask another question, and that question would be, what is the difference of their ages? And I think that's an important question to ask. So I'm going to draw a line here and a line here, and I'm going to ask, is this knowable? And you should be nodding very hard yes right now, because if Jane's unit is 9, every single other of these units are 9. And so the difference between Jane and her father is going to be 9 times 4, which is 36. Okay. So the difference in their ages is 36. And I want to ask you a question. Does that difference ever change? Is there ever a moment that will change? Well, of course, the answer to that is no. If Jane's father was 36 when she was born, he will always be 36 years older than her, and that remains a constant. So now we have another model to draw, and that's what Jane and her father's ages will be when they are related by 1 unit to 4 units. Okay, so when Jane's age is something, we're not sure what, her father's age will be something else, and we're not sure what that is either, but we do know that this difference is going to stay the same. This is still going to be 36. Well, so now this becomes a little easier, because if you have 3 units are 36, then 1 unit is 12. And that is 36 divided by 12. I'm sorry. Forgive me. Let me go back. It's 36 divided by 3 is 12. Okay? So each one of these is 12. Goodness, having a little bit of problems today. All right. All right. So each one of those units is 12, which means that Jane will be 12 when she is 1/4 of her father's age. Now, the question was, in how many years will Jane be 1/4 of her father's age? And so if she's 9 now and going to be 12 then, that's going to happen in 3 years, because 12 minus 9 is 3. So Jane will be Jane will be 1/4 of her dad's age in 3 years. And that's how you do it. This is a pretty typical before and after problem that you are going to have to go digging and think logically in order to solve the key, which would be what is the difference here? What can I use to explain some of this to me? There are other ways to solve the problem. You could have made a list. Starting with her dad being, this is kind of like method 2. If she is 9 and her dad is 45, when she's 10, her dad will be 46. When she's 11, her dad will be 47. And when she's 12, her dad will be 48. And you have struck on the point at which she is 1/4 of her father's age, because 12 is 1/4 of 48. If you had that in a fraction, actually, 12 over 48, you would see that it simplifies to 1/4. All right. I think, there we go. I think that's all I have for you today. If you have another problem, let's see, is there one in the book we could go over? Here's a fun one. Number 9 looks like a real fun one. Let's go ahead and do it. I don't have it written, but I'm reading it. It's number 9 in Extra Practice Book, page 30. Jasmine buys 21 cans of dog food. She gives 1/3 of the cans of dog food to a neighbor and keeps the rest for her puppy. Jasmine's puppy eats 4/7 of a can of dog food every day. How many days supply of dog food does Jasmine have for her puppy? Well, this is kind of fun. All right, so she buys 21 cans. All right, let's go. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21. All right, there's 21. There's a bar with 21. I hope it's 21. Anyway, and she gives 1/3 of the cans to her neighbor. All right, so that would be 7, because there are 3 7s in 21. 1, 2, 3, 4, 5, 6, 7 right here. Okay, her neighbor gets this. And so these are what she keeps. This is what her puppy gets. Okay. And the puppy is eating 4/7 of a can of dog food every day. Now, if the neighbor gets 7 cans, then the puppy gets 14 cans, right? And the question is, how many 4/7 are in 14, right? Which is a division problem. That's what you ask yourself when you have division. How many, oops, here we go again. I'm sorry. I don't know what's up with that. This is the problem that you ask yourself when you're doing division, right? So from here it's pretty straightforward. You're going to do 14 times 7/4. Okay, we're gonna simplify this. This comes down to 2, and this comes down to 7. And so you have you multiply across, and you get 7 times 7 equals 49. Divided by 2. And so 50 divided by 2 would be 25. This is going to be 24 and a half. It looks like Jane has 24 days. All right. And then this will be a half day left over. The correct response actually is rounding down because she doesn't have a full 25 days. She only has 24 and a half. And let me just do a quick check. I'm going to see if I'm right, if I got it right, if I led you down the garden path and have to delete it all. Wouldn't that be terrible? Yeah, great. Great, I got it right. Let's see. Can we do another fun one? Is there one? I could do these things all day, really. I love these problems. Ramon spends 2/5 of his monthly income on rent, 1/5 of his income on utilities, and 3/4 of the amount remaining on food and recreation. He saves the rest. If the amount he saves each month is $193.50, what is his monthly income? Well, this is interesting because it's cut up into fifths. So let's go ahead and let's just make 2 for every fifth. So 2, 4, 6, 8, 10. So this is going to be Ramon's monthly income, right? And we're going to cut it into fifths just so we have it subdivided. So here are the subdivisions for fifths. And 2/5 of this is going to be rent. And then 1/5 is utilities. So this next fifth is going to be utilities. So I'm going to put a U there for utilities. And the amount remaining of that, he spends 3/4 on food and recreation. So I'm gonna subdivide because there are 4 pieces here, right? So he spends 3/4 of the remaining, and I'm gonna color this a different color. Let's say yellow. I'm gonna shade it in yellow so that it's visible. All right, so we have 3/4 of what's remaining, and that is going to be food and entertainment. My word. Oops. Okay, food and rec. And then, so this piece is what he saves, and we're going to put an S there, right? And so the amount he saves every month, this is $193.50. Okay. Now, I just want to point out, if we were to go ahead and subdivide these, I'm gonna put a different color on it for the fifths. Okay. So you can clearly see where the fifths were. All right. Now, there are a couple of ways to solve this problem. The question is, what is his monthly income? What is the whole thing? How much does he earn every month? So we know that his savings is $193.50. And I think that, there are a couple of different ways to do this. Because you subdivided this into fifths, you could subdivide the whole thing. Do you see that? And now you have tenths, and this is one of those tenths. And so we can just multiply this by 10 to get the answer. And to do that, we just move our decimal place over, and that would make it $1,935 a month is what he earns. So, yeah, I think that's pretty straightforward, pretty easy one. Nice bar model, actually. It's a nice and straightforward one. Okay, let's try number 8 on page 30. Coach Rees orders 3 different colors of t-shirts for her soccer team. Of the different t-shirts, a fifth are red and the rest are white and blue. She orders an equal number of white and blue t-shirts. There is a total of 18 white t-shirts. How many t-shirts did she order? Okay, so this is a nice one. Let's go ahead and, all right. We're going to go ahead and do 5 units on this one. Actually, I'm going to make it 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go ahead and make it 10 just because it's easy to chop this up into fifths, okay? And that gives us just an ability to, let me make those shorter so we can write above them. That gives us some ability to write over them, and they're kind of nice and large. Okay, so 1/5 of these t-shirts are red. So let's go ahead and give that a red color. We know that this fifth, these are red t-shirts. And the rest are shared equally, white and blue, right? She orders an equal number of white and blue t-shirts. So I'm going to leave the white ones white, and I'm going to color the blue ones. Here's the blue ones. Okay. And so she said that there are 18 white t-shirts. So this number right here is 18. Okay. So the question is, how many did she order in all? Okay. Well, at this point, it's pretty straightforward because you see that there are 5. This is cut into fifths, and 2/5 is 18. So if 2 units is 18, then 1 unit is 9. That means that all of the units are 9, right? And 5 times 9 is 45. Okay. And we would just check back and make sure that that's right. And yeah, I think it is. I check back by saying, all right, if I have 18 and 18 and another 9, that should also get me to 45. And it does. So we're good. She orders 45 t-shirts in all.